Guys, today we'll deal about resonance. So this resonance is a first topic of your third unit. Actually this is eighth video I am doing. Now the resonance is a state of a condition. Actually simply you should say at resonance at some certain frequency the state of a circuit is said to be a resonance. So for simple we'll take an RLC circuit. So the resonance may occur in any circuit. So for explaining any basic concept, we initially take RLC circuit, RLC series circuit. Resonance may occur in RLC series circuit or many other circuits. In general, when dealing AC steady state analysis, for the same circuit, you will be given a voltage source of V with some frequency. Say some 50 Hz or some frequency omega or F. So the circuit input frequency is some omega. Let us say we have given input of V max of omega 1. So at omega 1 we given at the input for the circuit. So with magnitude of V at the frequency omega 1, we have given input of voltage to the RLC circuit. With the varying frequency, same magnitude V with different frequency, another input I have given. Again third is signal with same magnitude, I have given another input with same magnitude. This is omega 3. So if you observe carefully, the total impedance Z is written by Z equal to what? R plus j omega L plus 1 by j omega C. So that by this we will get R plus j of omega L plus minus of j by omega C, then equal to R plus j of XL minus XC. So here XL equal to what? Omega L. XC equal to what? XL equal to j omega L. XC equal to 1 by j omega C. If you observe carefully, so XL equal to j omega L and XC equal to 1 by j omega C. So here if you observe carefully, the varying frequency, the inductive reactance and capacitive reactances are depending, and the resistance is not depending on any frequency. So impedance across the resistance is not required. Impedance of the inductance is j omega L. So frequency omega is varying, inductance varying, omega is varying, capacitance varying. For example, if you plot omega 1, omega 3, if you take, now this is XL, XC. So if you give omega 1 frequency, you will be getting XL1 for example. You will be getting XL2 for omega 2. You will be getting XL3 for omega 3. And XC1, XC2 and XC3. So with varying input to frequencies, you will be getting different values of reactances. Okay. Now this resonance concept occurs where this is what? So J of X net. So this is net reactance. So in resonance is a concept where this net reactance becomes 0. That is imaginary part of any impedance becomes 0. Then that circuit is said to be resonant circuit. So if the condition is X net should be 0 means ultimately what is X net equal to? XL minus XC. So if this becomes 0, then ultimately what happens? XL equal to XC. That means the reactance across inductance and the reactance across capacitance will be, if they become 0, then means there will be a concept called resonance. So that means I intend to say if we vary the frequency from certain value to certain value at omega 2, there may be a condition that these two will be equal. So at that frequency we will call resonant frequency. The resonant frequency is designated by omega naught. In few textbooks it is designated omega naught. In few it is designated by omega r. That will become resonant frequency. Now I choose omega 2 as a resonant frequency. So ultimately you have to do like this. So this is called resonant frequency. Okay. So basing on this thing, we'll deal that. So anyway, resonance means for any impedance or for any admittance. What is admittance? Admittance is y equal to G plus JB. So J is called conductance and B is called susceptance. So conductance, so I need to explain this once now. So if you deal series circuit, any parallel series circuit, any series circuit, you will depend on impedance only. So that is R plus Jx. So X net reactance may be capacitor reactance or inductor reactance for RL circuit, RLC circuit, any circuit. If you see series circuit, if you see parallel circuit, this is parallel circuit. You will be relying on admittance. So admittance is equal to what? G plus JB. So G is called conductance. B is called susceptance. Susceptance. And Y is called admittance. That means inverse of impedance is admittance, inverse of resistance is conductance, inverse of reactance is susceptance. So for easy conveying way, so inductor total admittance is, so in admittance of this branch is Y1, admittance of this is Y2, admittance of this is Y3. So total admittance will be given by Y1 plus Y2 plus Y3. So here impedance is Z1, Z2, Z3. So total impedance means Z1 plus Z2 plus Z3. So overall, if you equivalent the impedance or equivalent admittance, you will be applying, you will be getting net impedance in real form and imaginary form, and net admittance is real form G plus J of B net. So if we equate this thing imaginary terms, then you will be getting a circuit with only resistance or only conductance. So inverse of conductance is resistance. So the resonance is also defined as when the circuit becomes resistive, when the net reactance is 0, is also called resonance. Okay. So we draw phasors in AC steady state analysis. So for example, if you take RLC series circuit, I explained in brief what happens with different inductance and capacitance values. So in this circuit, I is the common. So I is the common, we take base V. So I. So here what happens, the voltage across VL, across inductance. So when you take voltage across inductance, the current will be lagging. So we'll draw, this is VL. This is the case 1. Case 1 when XL is greater than XC. So you'll getting VL like this, and VC is short with respect to VL. Since the voltage across VC, then VL is greater than VC. So voltage is greater than, with respect to voltage across inductance is greater than voltage across capacitance. Therefore, you will be getting graph like this. So voltage across VR is, you will be doing like, so voltage VR is like this. So what happens now? So the resultant of these two circuits will be getting here. So total V here. So the resultant of VR and V net will be occurred like this. So now current V. So if you take output, the external. So when XL is greater than XC, you will be getting current lagging. So if similarly XC greater than XL, you will be getting what? So the same explanation already done this. So you will be getting the voltage V is lagging with respect to I. So current is leading. This will become leading circuit. When XL is equal to XC, then it will what happen? Same current is base, voltage VL is equal to voltage VC, and we will getting VR here. So resultant of these two will become some point here. This is VR. So resultant of these two will become a point here. Now extraction of this will become what? VR in phase with I. So this I will be in phase with VR. So now here phase difference is what? Phi equal to 0. So there is no, I is in phase with VR. So there is no phase difference. If there is no phase difference, then power factor is equal to what? Cos of phi. So cos of 0 is equal to 1. So at resonance, we have another concept called, so when net reactance will be equal to 0 is called resonance. When power factor of the circuit will become 1 is also resonance, and that in resonance you will be having net impedance. Impedance is R. So these three abstractions we got. Another is when the response is maximum, means it is also called resonance circuit. Okay. Now we will see some properties of this resonance circuit. This property means what we extracted now only. There are properties. There are 4 properties at the resonance circuit. The first property is X net equal to 0, and the impedance becomes resistive. That means circuit becomes resistive. The third one is will be unity power factor, that is cos of phi equal to 1, and fourth one is the response the current. Here current for RLC circuit, series circuit, RLC series circuit properties. The response of current I max, I is current will get maximum at resonance. That means ultimately the impedance will be minimum. Since by Ohm's law we got V equal to IZ, so if I equal to what? V by Z. If current is maximum, then ultimately inverse of current is impedance. The impedance will be minimum. So these are some abstractions from that resonance concept. So basing on this concept of resonance, we'll deal some characteristics curves. Now the real actually in this resonance concept, you won't solve nodal mesh analysis and all. So you have done until now many sums on nodal and meshes. You are way most familiar in solving different circuits, I hope. Now in this resonance, what you have to do is you have to analyze the circuit, analyze the concept. So with basing on frequency only, with varying frequency only, the entire subject is detailed here. So finding the resonance frequency is the way most important in resonance. So the sums and all will come up in this concept only. So you have another few concept when knowing resonance is quality factor, bandwidth. So for different circuits, you will be having a quality factor and bandwidth. That will be dealt later now. For example, the few characteristics what I said now. So at resonance, they will draw the characteristics of different elements here. So these characteristics are very much important in dealing the circuit. So in x-axis we take the omega. That means this is called frequency response. Frequency response. Frequency response means if you observe any response, frequency response means you are varying the frequency and we taking the response of different elements with varying frequency. So and at y-axis you take xc, xl, r and z. You have xl equal to j omega l, xc equal to minus of j omega c, xc equal to 1 by j omega c, xl equal to j omega l, and r and z equal to root of r square plus net square, and then x net equal to xl minus xc. So I am now wishing to draw the characteristic with varying frequency of xl. If you observe the formula, x equal to 1 by j omega c, that is minus of 1 by omega c. So that characteristics will be observed like this. So this is characteristics of xc, that is 1 by minus j of omega c. If you observe varying frequency, the first value is called maximum value. So if omega equal to 0 means what happen, xc will be equal to infinity. So at omega equal to 0 we are not giving any point, because at some infinity you will getting. So at some infinity there will be a point, we can't get that point. So that finite omega value, we are finding that value will be observed here. At finite omega 1 you are getting a point here. So if you increase in the frequency, the reactance of the capacitor is reduced to 0. So if you increase infinite value omega, then xc will become 0. So xc equal to 1 by of infinity will become 0. So it will become 0, but it will increase like this only. Okay, this is xc value. Now I want to take xl characteristics. So according to formula, this is j omega l. So if omega equal to 0, then xc equal to will become 0. So from 0 omega is increased, the characteristics will be observed like this. This is xl, j omega l. So if you wishing to find x net is what? xl minus of xc. So xl is 0, this is some finite value. So somewhere it will start here, up to it will be increasing, and at certain point that net reactance will become 0. this is net reactance becomes 0 means resonance point. This is omega naught, and it increases to a certain extent. So this is x net curve. So now if we want to r means r is not depending on a frequency, so so you can keep r at constant point. So maximum plus positive value, we draw a straight line, because there is no variation of resistance with varying frequency. You will draw this characteristics. If you want to z characteristics, now r value over and x net value over. So z is what? Root of r square plus x square. So magnitude of r square x square means, so if you observe, the characteristics will be this form. This is z form. If you observe carefully, x net means at a maximum value it is getting. So z is in the form of u curve. This is z characteristics is with varying frequency. You will be getting u curve. So you observe carefully this curve. This u curve will become minimum at resonance frequency at omega naught. That means this z value what will become? It will become r value. If z is equal to r mean, then it is called resonance. So at zero frequency, some extent value, this will be maximum value. So maximum value, if varying frequency, the reactor impedance is reducing, and at certain resonance frequency it is becoming r, and again if you increase the value it becoming some extremes value. So if we observe here, the net capacitance is higher than inductance. If capacitance is higher than inductance, that is Xc is greater than XL here. That means this will become, this left half will become RC circuit or leading circuit. Okay. Now if you observe carefully here, the XL is greater than XC. So XL is greater than XC means this will become RL circuit. This right side will become RL circuit, and it will be lagging. Okay. Basing on this characteristics of impedance, so what we are saying here, ultimately you are varying omega, you are observing XL, XC, you are getting Z. Basing on Z only, according to Ohm's law, what V equal to IZ. So I is also depending on Z only. So this is ultimate characteristics. Basing on this characteristics, we have a few abstractions. That is, we are extracted some points basing on this impedance react characteristics only. So by formula base only we will go the characteristics curves. So the Z characteristics means Z versus omega. If you observe means this is omega. So you will getting the graph of like this. This is Z. Okay, and this is R. At omega resonance frequency omega naught, Z will become R. So by this formula, the graph 2 will become what? So if you want to place I, so Z is inversely proportional to I. So inverse of U will get of inverted U. So the characteristics of current will be in this form. So this is inverse of, this is Z and this is I. So inverse of Z is I. So omega is varying, you are getting I response. So we have another characteristic 6. We have a few more characteristics 6, like phi versus omega. So I said here this will become RL circuit. So this is lagging. So if you plot the curve, what you will get means this is leading circuit. So if you take, this is a 5, this is 90 degrees, and this will become lagging. So this is omega naught, resonance frequency. The left half will become leading, the right half will become lagging. And so next we'll deal about a few concepts. Few responses also, not only I said concepts, we'll deal about a few responses here. So next video I'll explain the responses and a few more responses, and a few derivations are there. Thank you. After watching this video, just enroll your roll number in comment section and with the name also.